Hi there, guys. I'm looking at the 3D trig questions which I set on my Imaths. There's two of these questions which I've just been asked via an email to sort out, and I'll post it to everyone. Let me just show you the two questions. It's this one on the left-hand side and this one on the right-hand side here. And if you have a look, I'm starting with the one on the right-hand side, just because I thought the diagram would be slightly more difficult to draw, so I've already set that up. Now, my diagram here on the right-hand side is wrong. This is wrong. Okay, I've made a little mistake on this one. I started doing this video a minute ago and had to stop because I realized I made a mistake. But maybe you can see what the mistake is, but let me go through this to start off with, and then I'll tell you what the mistake is with this. So it says, the question says, in this square-based pyramid, find the angle between plane AVB, so that's this plane at the back, okay, and the base ABCD. Obviously, you can see where the base is, the flat ground, basically. Now, with these questions, you need to make sure you can identify a right-angled triangle in order to use trigonometry. Okay, and I've tried to identify the right-angled triangle at the back here. So the angle which we're looking for is the angle which joins up the plane at the back and the base here. So it's kind of like this angle here. Now, that's the same as this angle. So what I've done there is I've drawn a line down from V to E and then gone across from the base. And importantly, this thing here, this angle here, needs to be at right angles. So AB needs to be at right angles to this E to the midpoint of AB there. Okay, it has to be at right angles, otherwise it's not going to give you the right angle that you require there. Okay, so I've drawn this thing out again from this perspective. Okay, and that's what you see here. So you see B and C are at the bottom, V at the top, and E is in the middle there. It looks like it's the midpoint of BC, but obviously that's just a projection from the side there. It's just that's what we're seeing as the middle there. So we're getting this triangle is this triangle here. Okay, so what I've basically done is brought that B into here. Okay, but this length at the bottom is definitely 9.5 divided by 2, because it says it's a square-based pyramid. And we have 9.5 on this length, so we have 9.5 on this length. So this is B to C is 9.5. And there we go. Okay, and my mistake that I made is that this is not 11.4. 11.4 would be this length here. There's a bit more to this question, in fact, because the 11.5 is not this length here. It's not this length from V to, let's say, call that M, the midpoint there. Okay, so that is wrong. And in order to find that out, I'm going to need to take the isosceles triangle, AVB. Okay, so I've got 11.4 there, got 11.4 there, and I've got this midpoint at the bottom. And I've got B there and A there. I'm going to draw this down as well. And we know that this length on the bottom is 9.5 divided by 2 between B and M. Okay, so that's this length here. Okay, and now we have a right angle triangle. And from that right angle triangle, you can work out, let's just change color. You should be able to work out what this length is here. So we can do 11.4 squared, take away 9.5 over 2 squared and square root. That's just using Pythagoras to find out the height or one of your shorter lengths. Okay, so now once you've found that, that's going to give you this answer here. Once you've got that answer, you can then use normal trigonometry. Change color of pen again. And the normal trigonometry is going to be using, what we've got? We're looking for this angle. We've got the adjacent there. We've got the hypotenuse, which we've just found from over there. Okay, and so then we can use the cosine triangle. CAH. And you can do, to find the angle, you can say cos of theta. Now, I'm sure you know this, is equal to the adjacent divided by your hypotenuse, and then you can inverse cos once you put in your measurements there. Okay, hopefully that one is clear. And yeah, Good. Let's have a look at the next one then. So let's take the next one. I should see that it's there. Okay, in this one it says find the angle between the line AG and the plane ABCD. So in this case, we're looking for this angle here. So the right angle triangle, which is going to be important, is this right angle triangle here. You can see there's a right angle between AC and CG. So that's what we need. Let me just draw that one out over here. And this is the angle that we're looking for at the top. So I'm just redrawing this out. We've got C and we've got G there. And we know some of the measurements already. We know that C to G is 11.6. 11.6 is the same as this length, this length, this length, and this length. And okay, so I can see that we're going to need to use tan here because we can work out length A to C. And the length of A to C is quite easy to find because we have 11.5 in this length, and we have, well, let's call this one here 9.9. That's the height of this thing. And so now we can use on this one here, because what we're basically looking for is this dotted line. This dotted line is the same as this dotted line here, is the same as this height here. Okay, and now I'm drawing out this right angle triangle here. So this is B, C, A, and you can work out that dotted line by using Pythagoras with 9.9 and 11.5 to work out the longest length of the triangle there. Once you've got that length, you can then put it in here and you can use tan. That's pretty straightforward. Our triangle. So tan is equal to opposite over adjacent, so you can do tan of theta equals O divided by A, and then you can undo your tan by doing inverse tan. Okay, hope that helps, and good luck with your efforts here, and obviously keep going. Thank you for having a go at these ones early.